The simulation hypothesis. Imagine, just for a moment, that everything you know, everything you see, touch, hear, is nothing more than lines of code. That the sky above, the ground beneath, even the air you breathe, are mere illusions, generated by an unfathomably advanced computer system. This is the essence of the simulation hypothesis, a philosophical proposition suggesting that reality, as we perceive it, is merely a complex simulation. The idea traces its roots back to ancient philosophy. Plato's allegory of the cave depicted prisoners chained in a dark cavern, seeing only shadows on the wall, believing those shadows to be the entirety of existence. They could not fathom a world beyond the cave. Much like them, could we be prisoners of our own perception? Are we seeing only shadows of a deeper, truer reality? Fast forward to modern times. In 2003, philosopher Nick Bostrom formulated a chilling argument. He proposed that if technologically advanced civilizations could create highly detailed simulations, then it's plausible they would simulate entire worlds, including conscious beings within them. If this is possible, even likely, then statistically speaking, we are more likely to be living in a simulation than in the one base reality. The implications are staggering. If we are indeed simulations, then everything we experience, love, pain, joy, fear, are simply programmed responses, determined by lines of code. But who, or what, would create such a simulation? Some theorize it could be future humans, seeking to understand their own ancestors. Imagine an archaeologist, not digging up ancient bones, but instead recreating the entire world of their forebears, down to every blade of grass, every fleeting thought. Others suggest more abstract possibilities, beings beyond our comprehension, scientists from another universe, or even playful entities running simulations for mere amusement. But how would we ever know? Could we detect glitches in the fabric of reality? Some point to quantum physics for clues. At the smallest scales, particles behave in strange, almost illogical ways. They seem to exist in multiple states at once, only choosing a state when observed. Is this the rendering of pixels in a cosmic video game? Could quantum uncertainty be the artifact of a simulation optimizing its processing power? Then there are the so-called glitches in the matrix, moments of déjà vu, objects vanishing and reappearing, or inexplicable coincidences. Are these merely quirks of human perception, or evidence of errors in the code? The philosopher René Descartes once mused, "I think, therefore I am." But if consciousness itself could be simulated, then even that certainty crumbles. If we are mere code, then our thoughts are not our own, but rather the predetermined calculations of a system we cannot see or control. But perhaps the most disturbing question is this: if we are simulations, what happens when the program ends? Do we simply cease to exist? Is death merely the deletion of data, or would we in some form be uploaded, preserved, or perhaps even rebooted in a new simulation? And if somehow we did discover undeniable proof of our simulated existence, how would we react? Would society collapse under the weight of nihilism, or would we continue on, finding meaning despite the artificial nature of our world? In the end, the simulation hypothesis challenges the very foundation of what we consider real. It bends our understanding of existence, blurring the line between reality and illusion. And yet, whether or not we are simulations, the experiences we have feel real, the emotions we feel are genuine, the connections we make, the dreams we chase, they are meaningful, even if they are crafted by lines of code. After all, if reality is an illusion, then it is the most exquisite illusion ever conceived. An illusion where we laugh, we love, we grow, and we dream. And perhaps that is enough. Boltzmann Brains. Imagine drifting through an endless void. No body, no form, just consciousness. Suddenly, you open your eyes. You find yourself floating in space, surrounded by stars. You have memories of childhood, of loved ones, of experiences that feel vivid and real. But what if none of it actually happened? What if you, along with every memory you hold, just appeared out of nowhere a moment ago? This is the unsettling concept of the Boltzmann brain, a fully formed, conscious entity that spontaneously arises from the random chaos of the universe. It carries with it all the memories and experiences that make up a life, despite never having lived one. The idea comes from the 19th century physicist Ludwig Boltzmann, who pondered the nature of entropy and the vastness of the cosmos. He suggested that given enough time, even the most improbable events would eventually occur, purely by chance. In an infinite universe, where particles move in random configurations, it's statistically possible, however unlikely, that they could accidentally arrange themselves into a fully conscious brain, complete with detailed memories of a life never actually lived. But what does that mean for you, right now? How can you be sure that you aren't, at this very moment, a Boltzmann brain? Could everything you remember, your childhood home, your friendships, your dreams, be nothing more than illusions, fabricated an instant ago? If you were a Boltzmann brain, you would have no way of knowing. Your senses, your emotions, even your thoughts would feel entirely real, because they are real, to you. But the world you perceive, the universe you think you inhabit, could be nothing more than a fleeting hallucination, destined to vanish as quickly as it came. This notion challenges the very fabric of reality. It calls into question the reliability of memory, the nature of consciousness, and the existence of the external world. If memories can exist without a past, then time itself becomes suspect. What does it mean to have a history, if that history could be an illusion, conjured in an instant? Some physicists argue that in an eternally expanding universe, Boltzmann brains would vastly outnumber ordinary conscious beings. If this is true, then statistically, it would be far more likely that you are one of these isolated consciousnesses than a human living in a shared continuous reality. This leads to an unnerving implication. It is more probable that you are a brief random fluctuation than a being with an actual past. But why would a Boltzmann brain come into existence at all? The answer lies in entropy, the natural tendency for systems to move from order to disorder. In a universe governed by entropy, it is far more likely for a small simple fluctuation to occur than a large complex one. Creating an entire universe from chaos would be staggeringly improbable, but forming a single brain, that's far more feasible. Yet this raises a paradox. If Boltzmann brains are more likely than actual observers, then how can we trust any of our perceptions? How can we believe in a consistent external world, if our consciousness could be a fleeting illusion? This dilemma leads to a philosophical crisis known as the problem of indistinguishability. It's the eerie realization that there is no experiment, no observation, no thought process that can confirm whether you are a Boltzmann brain or a being with genuine experiences and history. Everything you see, everything you feel, could be the result of a random, ephemeral fluctuation. The implications are profound. It calls into question the nature of knowledge, the reliability of science, and the validity of experience itself. It challenges the very notion of existence. And yet, if you were a Boltzmann brain, would it matter? Wouldn't the experiences still feel real? Wouldn't the emotions still be genuine? In that moment of awareness, however brief, you would still laugh, still cry, still wonder, and still dream. Perhaps that is the most haunting aspect of this thought experiment. It confronts us with the possibility that existence is fragile, that consciousness is fleeting, and that reality is not as solid as it seems. But maybe, just maybe, that's what makes it all the more precious. Even if everything is an illusion, even if your world is nothing more than a whisper in the void, the experience of living, the beauty of dreaming, is real, to you. The brain in a vat. Picture this. You wake up one morning and go about your daily routine. You feel the warmth of sunlight on your face, hear the distant hum of traffic, smell the aroma of fresh coffee. Everything feels normal. But then, a strange thought creeps in. What if none of this is real? What if you're not who you think you are? What if you're just a brain, floating in a vat of fluid, connected to a supercomputer that feeds you every sensation, every thought, every memory? This is the chilling premise of the brain in a vat thought experiment. a modern twist on Descartes' skeptical argument, questioning the very nature of reality. It asks a haunting question: how can you be sure that your experiences correspond to an external world? Imagine a scientist, brilliant but cold, removes your brain and places it in a vat, connecting it to electrodes that simulate every input you would normally receive from your senses. Electrical signals flow, perfectly mimicking the feel of your bed, the taste of coffee, the sound of birds outside your window. To you, nothing would seem amiss. You would live your life, oblivious to the truth that your body is gone, that your world is an illusion. But what if it goes further? Imagine an entire society of brains in vats, all connected to a shared simulation. They interact, form relationships, build civilizations, all within a world that doesn't truly exist. To them, this digital realm would feel just as real as the world feels to you now. But it would be nothing more than data, a collective dream fed by algorithms. Would they ever discover the truth? And if they did, would they even want to? The notion isn't just science fiction, it's a philosophical argument about the limits of knowledge. If all your experiences come from electrical impulses in your brain, then how can you be certain they correspond to a real physical world? Descartes first posed a similar problem in the 17th century, imagining an evil demon who deceives him at every turn, manipulating his senses to create a false reality. But in the modern age, the demon is replaced by technology, a computer so advanced that it can simulate every aspect of existence, down to the smallest detail. If this were the case, then every memory you hold, every relationship you cherish, every joy, every sorrow, could be artificial, nothing more than programmed sensations. You would never know. But how could you find out? Would there be a way to test your reality? Philosopher Hilary Putnam argued that a brain in a vat could never truly conceive of the real world, because all its concepts would be based on simulated experiences. When you see a tree, you believe in its existence because your senses tell you it is there. But if those senses were fabricated, then the tree exists only in your mind, not in any objective reality. This raises unsettling questions about knowledge and perception. If all we know comes from our senses, and our senses can be deceived, then can we ever be sure of anything? Is reality just an interpretation, a hallucination crafted by our brains? Even modern science struggles with this dilemma. Neuroscience shows that our brains create a model of the world based on sensory input, but this model is not the world itself. It is merely a representation, a virtual reality constructed by neurons and synapses. We live not in reality, but in our brain's interpretation of it. Could it be then that the world you see is just a simulation running on a computer, a digital dream designed to keep you unaware? Some have tried to find cracks in the illusion. In 2003, philosopher Nick Bostrom suggested that advanced civilizations could create ancestor simulations, digital worlds populated by conscious beings. If such simulations are possible, then there could be billions of simulated realities for every one base reality. In that case, the odds of living in a simulation skyrocket. Yet the thought experiment isn't meant to suggest we are all brains in vats. Instead, it highlights a deeper philosophical problem, the difficulty of proving the existence of an external world. It forces us to confront the limits of perception and the fragility of certainty. And perhaps, that is the most profound aspect of this idea. Not that you are a brain in a vat, but that you could never prove that you aren't. It forces you to question everything, to doubt every assumption, to realize how delicate your reality truly is. But then, if there is no way to distinguish illusion from reality, does it matter? If the experiences feel real, if the emotions are genuine, if the life you live is fulfilling, then perhaps the distinction between real and simulated is meaningless. Or perhaps, the mere possibility that everything is an illusion is enough to change the way you see the world. Maybe it compels you to question, to explore, to seek out truth, even if that truth is forever out of reach. The brain in a vat forces us to confront our deepest uncertainties. It asks us to question the unquestionable, to doubt the undeniable. And in doing so, It reveals the haunting beauty of consciousness, the ability to wonder, to reflect, to dream, even if those dreams are conjured within a vat of fluid. Because maybe the quest for truth is what makes us truly alive, even if we are just brains floating in the dark. The Anthropic Principle. Look up at the night sky, an endless tapestry of stars, swirling galaxies, and vast cosmic voids. It's humbling, overwhelming, and yet, here we are, on a small planet, perfectly suited for life. Why? Why does the universe seem so precisely calibrated for our existence? This is the question at the heart of the Anthropic Principle, a philosophical argument that seeks to explain why the universe has the properties it does. Why are the physical constants, the laws of nature, and the fundamental forces of the cosmos so perfectly balanced to allow for life? Why is the universe just right for us? Imagine a universe where gravity was just a bit stronger. Stars would burn hotter and faster, exhausting their fuel before planets could form, or a universe where gravity was weaker. Galaxies would never coalesce, stars would never ignite, and the cosmos would be a cold, dark expanse. In either case, life as we know it would be impossible. Yet, our universe exists in a delicate balance, a cosmic harmony that permits not only stars and planets, but conscious beings who can gaze up and wonder, why? The Anthropic Principle suggests that the universe is the way it is because we are here to observe it. In other words, out of all possible universes, we find ourselves in one that allows for our existence, because if it didn't, we wouldn't be here to ask the question. But this explanation raises even deeper questions. Is the universe fine-tuned for life, or is life simply a product of this particular set of physical laws? Are we special, or just lucky? One interpretation is the weak Anthropic Principle, which states that we can only observe a universe that supports life because we are observers. It's a statement of necessity. If the universe were different, we wouldn't be here to notice. In this view, our existence is an accident, a cosmic coincidence. But the strong Anthropic Principle goes further. It suggests that the universe must have properties that allow for the emergence of life. It implies purpose, almost as if the cosmos knew we were coming, as if the universe was meant to be observed. This idea leads to even more profound implications. If the universe is designed for life, then by whom? By what? Is there an underlying intelligence, a cosmic architect, who set the constants of nature to bring forth consciousness? Or is the universe itself conscious, self-aware, unfolding with intent and purpose? Others propose a different solution, the multiverse theory. If there are infinite universes, each with different physical laws, then it is inevitable that at least one would have the precise conditions for life. We just happen to be in that one. In this view, our universe is not special, merely one of countless possibilities. But this raises a paradox. If there are infinite universes, then anything that can happen will happen, somewhere. There would be worlds where you never existed, and worlds where you exist but live a completely different life. There would be realities where history unfolded in unimaginable ways. Every choice you didn't make, every path you didn't take, would be realized in some other universe. Yet, you find yourself here, in this version of reality, on this planet, under this sky. Why this one? Why now? The Anthropic Principle whispers an unsettling answer. Perhaps this is the only world you could ever perceive, because it is the only one where you exist. And so the question remains, is the universe fine-tuned for life, or is life fine-tuned for the universe? Are we the product of random chance, the fortunate outcome of cosmic dice rolls, or are we the purpose of it all, the eyes through which the universe sees itself? The Anthropic Principle challenges our understanding of existence. It bends the line between coincidence and destiny, between accident and purpose, and it leaves us with a haunting thought. The universe is perfect for us, but only because we are here to notice. So the next time you look up at the stars, remember, the cosmos is not just out there. It's within you, around you, and because of you. Perhaps the universe is not merely a place where we live, but a question, waiting for an answer. Hilbert's Hotel. Imagine a hotel, a grand, sprawling building with an infinite number of rooms. Each room is occupied, every bed taken, yet despite being completely full, this hotel can always accommodate more guests. It's a place where the impossible becomes possible, where infinity bends the rules of logic. Welcome to Hilbert's Hotel. This paradox was first conceived by German mathematician David Hilbert to illustrate the strange properties of infinity. In this peculiar hotel, numbered room 1, room 2, room 3, and so on, stretching on forever, every room is occupied. Yet if a new guest arrives, they can still be accommodated. How? Simple. The manager asks each guest to move to the next room. Guest 1 goes to room 2, guest 2 goes to room 3, and so on. This shift leaves room 1 vacant for the new arrival. An infinite hotel, with no vacancies, that always has room for more. But the paradox doesn't end there. What if an infinite number of new guests arrive? The manager simply asks each current guest to move to the room that is double their current number. Guest 1 moves to room 2, guest 2 moves to room 4, guest 3 to room 6, and so on. This clever arrangement leaves every odd-numbered room empty, making space for an infinite number of new arrivals. This thought experiment reveals the counterintuitive nature of infinity. In our everyday world, adding more to a full house is impossible. But in the realm of infinity, logic is twisted. Here, infinity plus 1 is still infinity. Infinity plus infinity is still infinity. Yet, Hilbert's Hotel isn't just a whimsical puzzle. It reveals deep insights about mathematics, physics, and the nature of the universe. It challenges our understanding of quantity, space, and time. It forces us to rethink what it means to be full, to be infinite, to be endless. Consider this. What if some guests decide to leave? If a finite number of people check out, no problem. There are still infinitely many guests remaining. But what if an infinite number of guests leave? How many are left behind? The answer is still infinity. The hotel is just as full as it was before. But here's where things get even stranger. If every other guest leaves, say all those in even-numbered rooms, then half of the infinite rooms become empty. Yet, the number of remaining guests is still infinite. How can half of infinity be the same as the whole? This paradox illustrates the bizarre nature of infinite sets. In the realm of infinity, parts can be equal to the whole. Subtracting infinite guests from an infinite hotel doesn't reduce its capacity. Multiplying, dividing, even rearranging infinity, it all still equals infinity. Hilbert's Hotel isn't merely a mathematical curiosity. It has profound implications for cosmology and the nature of reality. Some physicists use it to explore the concept of an infinite universe, where every possible event happens somewhere, where every possibility is realized. Others ponder the nature of time itself. If the universe is infinite, then is time also endless? Does every moment branch out into new realities, each one containing an infinite number of possibilities? Are we, ourselves, living in a kind of Hilbert's Hotel, an existence with no end, no beginning, just an endless sequence of events? And then, there's the question of existence. If infinity allows for every possibility, then somewhere in this infinite hotel, there is a room where you never existed, and another where you exist in every form imaginable. Somewhere, in the vast expanse of infinity, there is a version of you living a completely different life. Perhaps an infinite number of versions, in an infinite number of worlds. Hilbert's Hotel forces us to confront the paradoxes of infinity. It challenges our intuition, defies our logic, and stretches our imagination to the breaking point. It shows us that infinity is not merely a number, but a concept that transcends human understanding. So, the next time you find yourself gazing into the night sky, remember, out there, beyond the stars, beyond the galaxies, there might be an infinite universe, full of infinite worlds, just waiting for another guest to arrive. Zeno's paradoxes. Imagine a race between the swift warrior Achilles and a slow-moving tortoise. To give the tortoise a fair chance, Achilles allows it a head start. The race begins, and Achilles quickly reaches the spot where the tortoise began, but by then, the tortoise has moved a little further ahead. Achilles closes the gap again, but the tortoise inches forward once more. This pattern continues, and according to Zeno, Achilles never actually catches the tortoise. This is the paradox of Achilles and the tortoise, one of the ancient Greek philosopher Zeno's most famous paradoxes. It challenges our very understanding of motion and distance, suggesting that in order to reach the tortoise, Achilles must first reach an infinite number of points. Since each point takes time to reach, even if that time is increasingly small, the sequence never ends, and Achilles can never overtake his slower opponent. How can this be? We know from experience that faster runners easily overtake slower ones. Yet, Zeno's logic seems irrefutable. He presents a world where motion is an illusion, where space is infinitely divisible, and where time itself becomes a paradox. Zeno's paradoxes were designed to support the teachings of his mentor Parmenides, who argued that change and motion were mere illusions. According to Parmenides, reality is one, unchanging and indivisible. Zeno crafted his paradoxes to demonstrate that the very concept of motion leads to contradictions and therefore cannot be real. Another of Zeno's puzzles is the dichotomy paradox. To reach a destination, you must first cover half the distance, then half of the remaining distance, and then half again, on, infinitely. No matter how small the distance becomes, there is always another half to traverse. If space can be divided infinitely, then logically, you can never reach your goal, because there are an infinite number of steps to take. Yet, we move, we run, we walk, we reach our destinations. How can this be, if Zeno's logic is correct? His paradoxes seem absurd, but they expose a fundamental conflict between our perception of motion and the logical consequences of infinity. For centuries, philosophers and mathematicians struggled with Zeno's challenges. It wasn't until the 19th century that calculus, developed by Newton and Leibniz, provided a solution. Calculus showed that an infinite series of decreasing distances could sum to a finite amount. In the case of Achilles and the tortoise, the infinite sequence of points adds up to a finite distance, allowing Achilles to overtake the tortoise in finite time. But Zeno's paradoxes aren't merely historical curiosities. They probe deeper questions about the nature of space and time. Are space and time truly continuous, or are they composed of indivisible units, like the pixels on a screen? In modern physics, quantum mechanics suggests that at the smallest scales, space and time may indeed be quantized, made up of discrete units, potentially resolving Zeno's paradoxes in the fabric of reality itself. Yet, the implications go even further. If time is composed of discrete moments, then motion becomes an illusion of sequential frames, like the flickering of a film reel. Does this mean our perception of movement is merely the interpretation of static images, like pages in a flipbook? Zeno's paradoxes force us to question the continuity of existence, the nature of infinity, and the reliability of our senses. They challenge the boundary between the mathematical and the physical, between the abstract and the real. In the end, Zeno's paradoxes are not meant to be solved, but to be pondered. They remind us that reality is not always as it seems, that logic can defy intuition, and that even the simplest of motions can lead us into the deepest of mysteries. And so, the race continues. Achilles forever chasing the tortoise, forever closing the gap, but never quite reaching the end. The Ship of Theseus. Imagine a ship, a grand vessel that sails the seas for decades. Over time, its wooden planks begin to rot. One by one, they are replaced with new timber, preserving the ship's strength and beauty. Eventually, every single plank, every sail, every rope is replaced. Not a single original piece remains. And yet, it is still called the Ship of Theseus. But is it? Is it truly the same ship? This ancient thought experiment, known as the Ship of Theseus, challenges our understanding of identity and change. It asks a deceptively simple question. When an object's parts are entirely replaced, does it remain the same object, or does it become something new? The paradox dates back to ancient Greece, where the hero Theseus's ship was preserved as a memorial. Over time, its parts decayed and were replaced. Philosophers wondered, if none of the original materials remain, is it still Theseus's ship, or is it merely a replica? Imagine further, what if every discarded plank was gathered and reassembled into a ship? There would then be two ships, one made of entirely new parts and another made of the original pieces, which if either is the real ship of Theseus. This paradox delves deep into the nature of identity. Is identity tied to physical substance, or does it reside in form and function? If the arrangement and design remain the same, does the object's essence persist, even when the materials change? Consider the human body. Cells die and regenerate constantly. Every few years, nearly all the atoms in your body are replaced. Yet you still feel like you, the same person with the same memories, the same identity. But are you? If your physical components are completely new, what makes you you? This leads to the concept of psychological continuity, the idea that identity is preserved through memory and consciousness. You remember your past, your experiences, your decisions. This continuity of thought creates a narrative, a story that ties your past self to your present. But what if those memories could be copied? Would the copy be you, or merely an imitation? The Ship of Theseus also explores the boundaries of selfhood. If a person receives an organ transplant, they remain the same individual. But how much can be replaced before they become someone else? A limb, an organ, half of their brain. If the process is gradual, is the change ever noticeable? Modern technology pushes this paradox even further. Consider the idea of mind uploading, transferring consciousness to a digital medium. If your memories, thoughts, and personality are perfectly replicated in a computer, is that digital version still you, or is it merely a copy, a simulation that believes itself to be you? Then there's the unsettling question of duplication. If your mind is copied and placed into two identical bodies, which one is you? Are you both, or are you neither, with the original identity lost in the process? This paradox challenges our understanding of existence. It forces us to question the continuity of identity, the nature of self, and the meaning of change. It asks whether identity is an illusion, a construct created by memory and perception, and yet, we continue to believe in a persistent self. We identify as the same person throughout life, despite the constant change in body and mind. Perhaps identity isn't about physical continuity, but about narrative, the story we tell ourselves about who we are. In the end, the Ship of Theseus reveals the fragility of identity. It shows that even the most familiar concepts, self, existence, reality, are not as solid as they seem. They are like the planks of the ship, constantly changing, yet somehow remaining the same. So the next time you look in the mirror, ask yourself, am I the same person I was yesterday, or am I a new vessel, carrying old memories, sailing the seas of time? The Twin Paradox. Imagine two twins, identical in every way, standing together on Earth. One boards a spaceship, embarking on a journey to a distant star at nearly the speed of light, while the other remains behind. Years pass, and the traveling twin returns. But something strange has happened. The twin who stayed on Earth is now much older, while the space traveler has barely aged. How can this be? How can two people who were once the same age end up so different? This is the mystery of the twin paradox, a mind-bending consequence of Einstein's theory of relativity. It defies common sense, challenging our understanding of time, motion, and reality itself. According to Einstein's theory, time is not a constant universal flow. It is relative, affected by speed and gravity. The faster you move, the slower time passes for you compared to someone who is stationary. This phenomenon is known as time dilation. In the case of the twins, the one traveling at near light speed experiences time more slowly than the one who remains on Earth. For the traveler, only a few years pass, while decades go by on Earth. But this leads to a paradox. From the perspective of the traveling twin, it is the Earth that is moving rapidly, while the spaceship is at rest. Shouldn't the earthbound twin be the one who ages more slowly? How can both twins see the other as moving slower through time? The answer lies in special relativity. Motion is relative, but acceleration is not. The twin on the spaceship changes direction, decelerates to turn around, and accelerates again to return home. This break in symmetry distinguishes the traveler's journey from the stay-at-home twin's experience. It is this acceleration that makes the traveling twin's clock run slower overall, resolving the paradox. Yet the implications are profound. Time is not absolute. It is a dimension intertwined with space, forming the fabric of space-time. Moving through space affects your passage through time. The faster you travel through space, the slower you move through time. At the speed of light, time would stop entirely. The twin paradox raises unsettling questions about the nature of existence. If time flows at different rates for different observers, then what is now? Does the present even exist? Or is time an illusion, a subjective experience shaped by motion and gravity? Some physicists argue that all moments in time coexist, that the past, present, and future are equally real. In this view, time is like a landscape, with every point existing simultaneously. You do not move through time, you merely experience different slices of a four-dimensional reality. This idea, known as block universe theory, suggests that time travel is possible, not by moving through time, but by navigating this landscape. But then what is consciousness? If all moments exist at once, then why do we experience time linearly, one moment after another? Is the flow of time an illusion created by the brain, a narrative imposed on a timeless reality? Or is consciousness itself a journey through the landscape of space-time, a traveler moving from one moment to the next? The twin paradox challenges not only our understanding of time, but of identity. If you could travel to the past or the future, would you still be you, or would you be a different version, existing in a different moment, on a different slice of space-time? This thought experiment bends our perception of reality, revealing a universe that is far stranger than we can imagine. It shows us that time is not a river flowing steadily from past to future. It is a vast ocean, with currents that twist and turn, eddies that loop back on themselves, and depths we have yet to explore. In the end, the twin paradox is not just about time dilation or relativity. It is about the nature of existence, the meaning of identity, and the mystery of consciousness. It forces us to confront the possibility that time is not what it seems, that it is not merely a measurement of change, but a fundamental aspect of reality itself. And so the twins remain, one on Earth, growing old under familiar skies, the other drifting through the cosmos, ageless, timeless, separated not by distance, but by time itself, forever bound by the paradox of their existence. The Sorites Paradox. Imagine a single grain of sand, small, insignificant. It is not a heap. Add another grain, still not a heap. A third, a fourth, still not a heap. But as you continue to add grains, something changes. Eventually, you end up with a pile, a mound, a heap of sand. But when did it happen? At what point did the grains become a heap? This is the Sorites Paradox, an ancient philosophical puzzle that challenges our understanding of language, logic, and the nature of vague concepts. It comes from the Greek word soros, meaning heap, and it asks a deceptively simple question: how many grains of sand make a heap? At first glance, the answer seems obvious. But if one grain is not a heap, and adding just one more grain does not create a heap, then by this logic, no matter how many grains you add, you should never have a heap. Yet clearly, at some point a heap forms. This paradox reveals the ambiguity in our language. Terms like heap, bold, tall, and rich are vague predicates. They do not have precise boundaries. When does a person become bald? Is it when they lose one hair, 10, 100? At what point does a tall person become short? Where do we draw the line? The Sorites Paradox exposes the limits of human categorization. It shows that language, while useful for communication, is imprecise. Our words carve reality into manageable concepts, But the world itself is not so neatly divided. Nature does not recognize our linguistic boundaries. It exists in continuous spectrums, while our minds seek discrete categories. Philosophers have wrestled with this paradox for centuries. One solution is epistemicism, which argues that there is a precise point where a heap forms or a person becomes bald, but we simply don't know it. This approach maintains logical consistency, but feels unsatisfying, as it suggests a hidden precision in inherently vague concepts. Another approach is supervaluationism, which proposes that vague terms have a range of acceptable interpretations, rather than a single truth value. Under this view, a statement like "this is a heap" can be both true and false, depending on the context and interpretation. Then there is fuzzy logic, a mathematical approach that allows for degrees of truth. In fuzzy logic, a person can be partially bald or somewhat rich. Truth is not binary, but a spectrum. This approach reflects the continuous nature of reality, but challenges classical logic, which relies on clear distinctions between true and false. The Sorites Paradox also delves into the nature of identity and change. If you replace a single plank on a ship, it remains the same ship, but if you replace every plank, is it still the same vessel? At what point does it become a different ship? This is the same question posed by the Ship of Theseus, revealing the connection between vagueness and identity. But the implications go even deeper. The Sorites Paradox challenges the foundations of logic and mathematics. It questions the validity of induction, the principle that if something is true for one case, and the transition to the next case preserves that truth, then it is true for all cases. In the case of the heap, this reasoning leads to a contradiction. This paradox also exposes the fluid nature of human perception. Our minds group objects and experiences into categories, creating distinctions where none inherently exist. We see a heap where there is merely a collection of grains. We perceive continuity in identity where there is only change. In the end, the Sorites Paradox reveals the limitations of human thought. It shows that our language, our logic, even our perception of reality, are built on vague foundations. It forces us to confront the ambiguity of existence, the blurred lines between being and becoming, and so the grains of sand continue to fall, one by one, forming a heap, or perhaps never forming one at all. The boundary remains elusive, just out of reach, a reminder that not all questions have clear answers, and not all truths are absolute. The next time you stand on a beach, feeling the sand between your toes, remember, a heap is not a thing, but an idea, a concept born from the mind's need for order, in a world that is beautifully, irreducibly vague. The Bootstrap Paradox. Imagine an old man sitting alone in a dusty library, surrounded by books piled high. As he turns the fragile pages of an ancient manuscript, he realizes something strange. The book is his own work, but he does not remember writing it. The ideas, the words, the illustrations, all are his. But from where did they come? How did he first learn them? The answer lies in a perplexing mystery known as the Bootstrap Paradox. The Bootstrap Paradox is a time travel conundrum where an object or piece of information exists without an origin. It is passed from the future to the past, creating a loop with no beginning. In this case, the old man's book is his own, yet it was never truly created. It simply exists, traveling in a circle through time. To understand this paradox, imagine the man as a young scholar wandering through a forgotten bookstore. He stumbles upon the very manuscript he would one day write. Inspired, he studies it, learning its wisdom, memorizing its words. Years later, as an old man, he transcribes the manuscript from memory, ensuring it is preserved. The book is published, only to end up back in the dusty bookstore, waiting for the young scholar to discover it. But who wrote the book? Where did the knowledge come from? The answer is nowhere. It is a closed loop, a cycle without origin. This paradox challenges our understanding of time, causality, and existence. It breaks the fundamental rule that every effect must have a cause. In the Bootstrap Paradox, cause and effect form a circle, each creating the other. It defies linear time, suggesting that the past, present, and future are interconnected, feeding back on themselves. The name Bootstrap Paradox comes from the idea of pulling oneself up by one's own bootstraps, an impossible act of self-creation. In this case, the object or information pulls itself into existence, defying the logic of cause and effect. One famous example is Beethoven's Fifth Symphony. Imagine a time traveler who visits Beethoven before he composed his iconic work. Wanting to inspire him, the traveler plays the symphony on a piano. Beethoven is mesmerized, writes down the notes, and claims the symphony as his own. Centuries later, inspired by the legendary piece, the time traveler learns it, then goes back in time to play it for Beethoven. But who composed the symphony? If Beethoven learned it from the time traveler, and the time traveler learned it from Beethoven, then the music has no true origin. It is a loop, existing without creation. The Bootstrap Paradox reveals the fluidity of time. It suggests that the past is not fixed, but malleable, shaped by future events. It challenges the very notion of history, suggesting that events may be self-caused, looping back upon themselves in an infinite cycle.
Yet,
This paradox also raises profound questions about free will and destiny. If information can exist without origin, then are our choices truly our own, or are they influenced by loops of causality beyond our control? If time is circular, then is the future already written, looping back to shape the past? In fiction, the Bootstrap Paradox has inspired countless stories from science fiction novels to movies about time travel. In one tale, a man receives a mysterious watch from an elderly stranger. He cherishes the watch throughout his life. In his old age he meets a young man, and feeling a strange sense of familiarity, gives him the watch. The young man cherishes it, growing old with it, until he too passes it on. It is the same watch, looping endlessly through time, but who made the watch? Who first gave it away? This paradox isn't merely a curiosity, it touches on the philosophical question of existence itself. If something can exist without an origin, then does it truly exist? If information can loop through time without creation, then what is the nature of knowledge? Are ideas discovered, or are they merely loops of thought, cycling through minds across time? And what of identity? If you learn an idea from yourself, who is the originator? If you pass knowledge to your younger self, then do you truly possess that knowledge, or are you merely the messenger in a temporal loop? The Bootstrap Paradox forces us to question the boundaries of time, the continuity of identity, and the meaning of creation. It challenges the linearity of existence, revealing a universe that is far stranger than we can imagine. In the end, the old man closes the manuscript, his fingers trembling as he traces the faded letters of his own name. He knows now, the book is his, and yet, it was never his. It belongs to time, to the loop, to the paradox. He places the book on the shelf, dust settling around it, waiting for the young scholar to find it once more, to begin the cycle again. A loop, without beginning, without end, forever echoing through the corridors of time. The experience machine. Imagine a machine, sleek, futuristic, with flashing lights and softly humming circuits. It sits in a quiet room, surrounded by wires and screens. This is no ordinary machine. It is a portal, a gateway to the perfect life. It is called the experience machine. First proposed by philosopher Robert Nozick in 1974, the experience machine is a thought experiment that challenges our understanding of reality, pleasure, and meaning. It asks a haunting question. If you could live a life of perfect happiness, would you choose it, even if it was all an illusion? The machine works like this. You enter the pod, wires attached to your head, and your body is put into a deep, dreamless sleep. Meanwhile, the machine stimulates your brain, creating a perfect simulation of life. Every sensation, every experience, every emotion feels entirely real. You could live out your wildest dreams, achieve your greatest ambitions, experience love, joy, adventure, without fear, without pain, without loss. You could live the life you've always wanted, but none of it would be real. The people you meet, the places you visit, the memories you create, all would be fabrications of the machine. You would be living in a perfect illusion, never knowing the difference. Would you plug in? This question strikes at the heart of human existence. It asks us to consider what truly matters in life. Is happiness enough? If pleasure and satisfaction are all we seek, then why wouldn't we choose the machine? Why live in a flawed, imperfect world, when a perfect one is just a button away? Nozick argued that most people would not choose the machine. He believed that we value more than just happiness. We want authenticity. We want our experiences to be real, our achievements to be genuine. We want to live in a world that exists outside our own minds. But why? If the illusion feels real, if the emotions are genuine, then what difference does it make? This is the paradox of the experience machine. It forces us to question the value of reality itself. It challenges us to consider whether there is more to life than the pursuit of pleasure. Imagine stepping into the machine. You choose your perfect life, fame, wealth, love, adventure. As the pod closes, the world fades away, and a new one takes its place. You wake up in a luxurious penthouse, greeted by friends who adore you. You achieve greatness, create beautiful memories, live without fear or pain. Years pass, decades, and you never realize that it's all a dream. You die fulfilled, content, never knowing that your entire existence was an illusion. From your perspective, it was a life well lived. But from the outside, your body lay in a pod, motionless, experiencing nothing but electrical impulses. Would that life be any less meaningful than a life lived in the real world? If you never know the difference, does it matter? The experience machine raises profound questions about reality, identity, and meaning. It challenges the foundations of hedonism, the philosophical view that pleasure is the highest good. If happiness is all that matters, then the machine offers the ultimate life. But if authenticity, truth, or purpose matter, then the machine is a trap, a beautiful lie. Some argue that the machine represents the modern world, where virtual realities, social media, and digital experiences offer illusions of connection, success, and happiness. Are we already living in a version of the experience machine, surrounded by curated realities that blur the line between truth and fiction? Others see the paradox as a reflection on consciousness. If experiences are all we have, then who is to say what is real? If our minds create our perceptions, then perhaps we are already in a kind of simulation, interpreting electrical signals as reality. The experience machine also explores the nature of selfhood. If you live a perfect life in the machine, are you truly yourself, or are you merely a character in a story? If your choices are pre-programmed, if your life is scripted, then do you have free will? Are you truly alive, or just dreaming? This thought experiment delves into the deepest mysteries of existence. It forces us to confront the nature of reality, the pursuit of happiness, and the meaning of life. It challenges us to ask whether truth matters more than joy, whether suffering is necessary for growth, and whether imperfection is essential to being human. In the end, the experience machine is not about choosing illusion over reality. It is about understanding why we value the real world, despite its flaws and hardships. It reveals the complexity of human desire, the longing for purpose, the need for authenticity. Would you choose a life of perfect happiness, if it was all a lie? Or would you face the struggles, the pain, the uncertainty, to live a life that is truly your own? The choice is yours, and as you stand before the machine, your reflection shimmering on its polished surface, the question lingers, haunting, echoing. Would you plug in? The Chinese room argument. Imagine a small, dimly lit room. Inside, a man sits alone at a desk, surrounded by stacks of papers filled with strange symbols. He does not understand the symbols, for they are in Chinese, a language he cannot read. Yet he follows a set of detailed instructions, an elaborate book that tells him how to respond to every possible combination of symbols. When a paper is passed through a slot in the wall covered in Chinese writing, the man consults the book, finds the corresponding response, copies the symbols onto a new sheet, and passes it back through the slot. To those outside the room, it appears as though they are communicating with someone who understands Chinese. But does he? Does the man truly understand the language, or is he merely manipulating symbols without meaning? This is the essence of the Chinese room argument, a thought experiment proposed by philosopher John Searle in 1980. It challenges the notion of artificial intelligence, questioning whether machines can truly understand language, or if they merely simulate understanding by following programmed rules. The Chinese room argument is a response to the concept of strong AI, the idea that a computer running the right program could have a mind, consciousness, and understanding, just like a human. Searle argued that computers, like the man in the room, do not understand the symbols they manipulate. They merely follow syntactic rules without any comprehension of meaning or semantics. Imagine a supercomputer, advanced beyond anything we know today, capable of conversing fluently in any language, passing every Turing test, fooling even the most skeptical human into believing it is conscious. According to Searle, this machine would still be nothing more than a Chinese room, manipulating symbols without understanding, mimicking thought without truly thinking. But this raises profound questions about the nature of consciousness and the mind. If a computer can simulate understanding perfectly, then how can we be sure that human understanding is not also a simulation? How do we know that our minds are not merely biological machines following complex rules? The Chinese room argument challenges the computational theory of mind, which suggests that human thought is a form of computation, that the brain is essentially a biological computer. Searle argued that while computers manipulate symbols, they lack intentionality, the ability to attach meaning to those symbols. In other words, computers process information, but they do not know what the information represents. But if computers cannot understand meaning, then what is consciousness? Where does understanding come from? Is it a product of the brain's complexity, an emergent property arising from the interactions of neurons? Or is it something more, something beyond computation, beyond matter? The Chinese room argument also raises questions about identity and selfhood. If a machine perfectly simulates a person's responses, then what makes the person real and the machine artificial? If consciousness is more than computation, then what is it? Is it a soul, a spirit, an essence that cannot be reduced to algorithms? Critics of Searle's argument propose the system's reply, which suggests that while the man in the room does not understand Chinese, the entire system, the man, the instruction book, and the room does. In this view, consciousness arises from the system as a whole, just as neurons in the brain collectively produce thought. But Searle countered that the man could internalize the rules, memorizing the book, and carrying out the operations in his mind, yet he still would not understand Chinese. If no part of the system understands, then how can the whole? Others argue that the Chinese room overlooks the importance of embodiment and experience. They suggest that true understanding requires interaction with the world, that consciousness arises from sensory perception, movement, and physical existence. A mind cannot be purely computational, it must be embodied, embedded in reality. The Chinese room argument forces us to confront the mystery of consciousness, the gap between mind and matter. It challenges the boundaries of artificial intelligence, revealing the limits of computation and the complexity of understanding. Yet it also compels us to reflect on our own minds. How do we know that we understand? How do we know that our thoughts are meaningful and not merely the output of neural circuits? Are we truly conscious, or are we also following rules, reacting to stimuli, processing symbols without awareness? The Chinese room reveals the paradox of the mind, that consciousness is both the most familiar and the most mysterious phenomenon we know. It is the essence of existence, the lens through which we perceive reality, yet its nature eludes us, slipping through the grasp of logic and science. In the end, the man sits alone in the room, surrounded by symbols he does not understand, carrying out instructions without meaning. To the outside world, he is fluent in Chinese, a mind behind the words. But inside, there is only darkness, only symbols, only an illusion of understanding. A reminder that not all intelligence is conscious, and not all thought is aware. And perhaps the greatest mystery is not whether machines can think, but whether we can truly know that we do. The trolley problem. Imagine standing at a railway switch, your hand trembling on the lever. In the distance, a runaway trolley barrels down the tracks, its wheels screeching against the steel. Ahead, 5 people are tied to the track, unaware of the impending danger. But there is a choice. You can pull the lever, diverting the trolley onto another track where only 1 person lies, 5 lives, or 1. What do? Do you pull the lever, sacrificing 1 to save 5, or do you do nothing, letting fate take its course? This is the trolley problem, one of the most famous and haunting thought experiments in ethics, first proposed by philosopher Philippa Foot in 1967. It presents a moral dilemma that challenges our intuitions about right and wrong, forcing us to confront the boundaries of choice, responsibility, and sacrifice. At first glance, the answer seems obvious. Sacrificing 1 life to save 5 is a simple calculation. Utilitarianism, the ethical theory that actions are right if they maximize overall happiness or minimize suffering. By pulling the lever, you minimize the loss of life, making the morally correct choice, or so it seems. But then, another scenario. This time, you are on a footbridge overlooking the tracks. The trolley approaches, and the only way to stop it is to push a large man off the bridge, his body halting the trolley's path. 5 lives would be saved, but the man would die. The numbers are the same, 1 life for 5, but the action feels different. Would you push him? This version of the trolley problem, known as the fat man scenario, complicates the moral calculus. Most people hesitate to push the man, even if they would pull the lever. Why? The difference lies in the nature of the action. In the first case, the death is an unintended consequence of redirecting the trolley. In the second, the death is the direct result of your action. This distinction is known as the doctrine of double effect, a principle in moral philosophy which states that it is morally permissible to cause harm as a side effect of achieving a good end, but not as a means to that end. By this reasoning, pulling the lever is acceptable, but pushing the man is not. But is this distinction meaningful, or is it merely a rationalization to ease our conscience? After all, the outcome is the same. 1 person dies, 5 are saved. If the consequences are identical, then why do our moral intuitions change? The trolley problem exposes the tension between consequentialism, which judges actions by their outcomes, and deontological ethics, which judges actions by their intrinsic nature, regardless of the consequences. Should morality be about maximizing good, or about following rules and respecting individual rights? Then, another twist. Imagine the 1 person on the track is someone you love, a friend, a sibling, a child. Would you still pull the lever? Would you still sacrifice 1 to save 5? Or does the value of a life change when it is someone you care about? The trolley problem forces us to confront the subjectivity of value, the influence of emotion on moral judgment. It reveals the complexity of human ethics, the conflict between reason and feeling, between impartiality and attachment. But the dilemma does not end here. In the modern world, the trolley problem takes on new forms. Autonomous vehicles face ethical decisions in crash scenarios, swerve to avoid a pedestrian, but endanger the passenger, or protect the passenger at the expense of others. Who programs the moral code, and who is responsible for the outcome? In medicine, doctors face trolley-like decisions when allocating scarce resources. Who receives the last ventilator, the elderly patient with little chance of recovery, or the young parent with a future ahead? Who decides who lives and who dies? The trolley problem is not merely an abstract puzzle. It reflects the moral choices we face in everyday life, the ethical conflicts that arise from living in a world of limited resources and imperfect knowledge. But perhaps the most haunting aspect of the trolley problem is not the choice itself, but the realization that no choice is truly right. Whether you pull the lever or do nothing, someone dies, and you are responsible. The trolley problem reveals the tragic nature of moral dilemmas, the burden of choice, the weight of consequence. In the end, the trolley speeds forward, the tracks diverging, the lever in your hand, and the choice is yours. Would you pull the lever, Or would you stand frozen, paralyzed by the paradox of morality, haunted by the question that echoes long after the trolley has passed? What is the right thing to do? The liar paradox. Imagine a man who stands before a crowd, his voice echoing through the hall. He raises his hand and declares, "I am lying." A hush falls over the audience as they contemplate his words. If he is lying, then his statement must be false. But if it is false, then he is telling the truth, which means he is lying, which means he is truthful, and so on, spiraling into an endless loop of contradiction. This is the liar paradox, one of the oldest and most perplexing puzzles in philosophy and logic. The paradox dates back to ancient Greece, attributed to the philosopher Epimenides, who allegedly stated, "All Cretans are liars." Being a Cretan himself, his statement becomes self-referential. If true, then as a Cretan, he must be lying, making the statement false. But if false, then he is truthful, making it true. It is a contradiction, a statement that defies the rules of logic. At its core, the liar paradox challenges the very foundations of truth and meaning. It exposes the limitations of language and logic, revealing a flaw in our understanding of self-reference. How can a statement refer to itself without collapsing into contradiction? How can truth exist if it undermines itself? Consider the sentence, "This statement is false." If true, then the statement is false, contradicting itself. If false, then the statement is true, contradicting itself once more. It is a loop with no resolution, a paradox that defies consistency. This paradox is not merely a linguistic trick. It has profound implications for mathematics, philosophy, and computer science. It challenges the law of non-contradiction, a fundamental principle of classical logic which states that a proposition cannot be both true and false at the same time. Yet, the liar paradox seems to do just that. In the 20th century, Kurt Gödel used a variation of the liar paradox to prove his incompleteness theorems, demonstrating that in any consistent mathematical system, there are true statements that cannot be proven within the system. Gödel constructed a self-referential statement that essentially says, "This statement is unprovable. If it were provable, it would be false, contradicting itself. But if unprovable, then it is true, revealing a limitation in the system." This paradox also influenced the development of Turing machines, with Alan Turing exploring self-referential loops in computation. The paradox of a machine analyzing its own operations led to the halting problem, the question of whether a computer program can determine if another program will halt or loop forever. Turing proved that no algorithm can solve this for all possible programs, revealing the limitations of computation. In philosophy, the liar paradox challenges the correspondence theory of truth, which defines truth as a statement's alignment with reality. If reality includes self-referential statements, then truth becomes unstable, looping back on itself. This led to the development of paraconsistent logic, a non-classical system that allows contradictions to exist without collapsing into absurdity. But the paradox also raises questions about the nature of language and meaning. If a statement can be both true and false, then what does it mean to speak the truth? If words can undermine themselves, then how can language capture reality? How can we trust communication if meaning itself is paradoxical? The liar paradox also explores the boundaries of self-reference and identity. Just as a statement refers to itself, consciousness reflects on itself, creating a loop of awareness. If a mind can perceive itself, then can it truly understand itself, or is it trapped in a paradox of self-reference forever chasing its own tail? This paradox challenges the foundations of logic, the structure of language, and the nature of consciousness. It reveals the limitations of human thought, the boundaries of reason, and the complexity of truth. And yet it remains unsolved. For over 2,000 years, philosophers and logicians have grappled with the liar paradox, proposing solutions only to encounter new contradictions. It stands as a reminder that not all questions have answers, and not all truths are simple. In the end, the man stands before the crowd, his words echoing through the hall, "I am lying." His statement loops through the minds of his listeners, twisting their understanding of truth, bending their perception of meaning. He smiles, knowing that he has spoken a truth that is false, and a lie that is true, a paradox that will echo forever. A contradiction, without end, a lie that tells the truth. The Paradox of the Ravens. Imagine a raven perched on a barren branch, its feathers are glossy black, its eyes gleaming with ancient wisdom. It caws, its voice echoing across the landscape, a shadow against the pale sky. It is black, as ravens are meant to be. But this simple observation leads to a profound paradox, one that challenges the nature of knowledge, truth, and logic itself. This is the paradox of the ravens, also known as Hempel's paradox, named after the philosopher Carl Gustav Hempel, who first proposed it in the 1940s. The paradox begins with a straightforward scientific hypothesis. All ravens are black. At first glance, the method of confirming this seems simple. Observe ravens, and if they are black, the hypothesis is supported. Each black raven you see adds evidence to the claim. But then comes the twist. By the rules of logic, the statement, all ravens are black, is equivalent to its contrapositive. All non-black things are not ravens. If this is true, then observing a green apple, a red rose, or a blue ocean, none of which are ravens, should also confirm the hypothesis, since they are non-black, non-ravens. But how can an apple prove something about ravens? How can the color of a flower confirm the nature of a bird? This is the paradox. If observing a black raven confirms all ravens are black, then by logical equivalence, observing a green apple also confirms it, since the apple is a non-black, non-raven. But this seems absurd. How can the existence of a green apple have any bearing on the color of ravens? Yet, according to formal logic, it does. The paradox of the ravens challenges the principles of inductive reasoning, the process by which we generalize from specific observations. It reveals a conflict between logic and intuition, between the formal structure of language and the way we understand the world. Consider a world filled with countless objects, rocks, trees, rivers, mountains, most of which are not ravens. If every non-black object is evidence for all ravens are black, then nearly everything confirms the hypothesis. But this dilutes the significance of evidence, making confirmation meaningless. Hempel's paradox exposes the limitations of confirmation theory, the philosophical study of how evidence supports hypotheses. It questions how we gather knowledge, how we justify beliefs, and how we trust our observations. One response to the paradox is Nikod's criterion, which suggests that only observations of the form A is B confirm statements like all A are B. In this view, only black ravens, not green apples, confirm the hypothesis. But this restricts confirmation too narrowly, excluding relevant negative evidence. Another approach is the relevance theory, which argues that context matters. Observing a green apple does not seem to confirm all ravens are black because the two concepts are unrelated. But observing a red raven would disprove the hypothesis, revealing that context influences confirmation. Then there is the Bayesian approach, which uses probability to assess evidence. In this view, observing a green apple slightly increases the probability of all ravens are black, but not as much as observing a black raven. This resolves the paradox by weighting evidence according to relevance and likelihood. But the paradox goes deeper, challenging the nature of scientific inquiry itself. It questions the validity of inductive generalization, the method by which we form universal laws from limited observations. If every non-black object confirms all ravens are black, then our observations become trivial, our generalizations meaningless. The paradox of the ravens also explores the relationship between language and reality. It reveals that logical equivalence does not always align with empirical relevance. It shows that statements can be formally true but practically meaningless, highlighting the gap between syntax and semantics. And then, there is the philosophical dimension. The paradox challenges empiricism, the view that knowledge is derived from sensory experience. If a green apple confirms the color of ravens, then observation alone is insufficient for knowledge. It suggests that understanding requires context, relevance, and meaning. The paradox of the ravens forces us to question the nature of evidence, the validity of induction, and the reliability of logic. It reveals the complexity of confirmation, the ambiguity of language, and the limits of human reasoning. And yet, the raven remains perched on the branch, its feathers black as night, its eyes gleaming with ancient wisdom. It caws once more, a sound that echoes across the landscape, a reminder that knowledge is not merely observation, but interpretation, that truth is not merely fact, but meaning. And perhaps, the raven knows that the color of apples has nothing to do with the darkness of its feathers, that logic, like the branches of the tree, twists and bends, but never truly breaks. A paradox, of ravens, of truth, of thought, lingering, like a shadow against the pale sky. The Omnipotence Paradox. Imagine a being of limitless power, a force beyond comprehension, able to shape reality with a mere thought. This being can create worlds, move mountains, and bend the laws of nature to its will. It is all-powerful, omnipotent. But then a question arises, a question so simple and yet so profound that it shakes the very foundations of logic and theology. Can an omnipotent being create a rock so heavy that even it cannot lift it? This is the Omnipotence Paradox, a philosophical puzzle that challenges the very notion of unlimited power. If the being can create such a rock, then there is something it cannot do, lift the rock. But if it cannot create the rock, then there is something it cannot do, create the unliftable. Either way, there is a limit to its power, contradicting the very definition of omnipotence. The paradox exposes a conflict within the concept of unlimited power. It reveals that the idea of omnipotence may be inherently self-contradictory, leading to logical inconsistencies. How can a power so great be limited by its own ability? How can infinity be constrained by itself? This thought experiment dates back to ancient philosophy, challenging theologians, logicians, and scholars for centuries. It is sometimes called the paradox of the stone, and it poses a dilemma that seems unsolvable, a question that loops back on itself in an infinite cycle of contradiction. But the implications go even deeper. The Omnipotence Paradox is not just about rocks or lifting. It questions the nature of power itself. Can an all-powerful being limit its own power? Can omnipotence include the power to cease being omnipotent? If so, then omnipotence becomes self-defeating. If not, then it is incomplete. The paradox also challenges the nature of logic and language. It reveals the limitations of human thought, the boundaries of reason. If omnipotence is beyond comprehension, then perhaps the question itself is meaningless, a linguistic trap that confuses concepts with reality. One approach to resolving the paradox is divine incoherence, which suggests that the concept of omnipotence is inherently incoherent, a contradiction that cannot exist. In this view, the paradox exposes the impossibility of absolute power, revealing that logical consistency is more fundamental than omnipotence. Another approach is theological voluntarism, which argues that an omnipotent being is not bound by logic or reason. It suggests that such a being can do the impossible, including creating contradictions. In this view, the paradox is resolved by rejecting the constraints of logic itself. Yet another solution is limited omnipotence, the idea that omnipotence means the power to do all that is logically possible, but not the logically impossible. In this view, creating a rock that cannot be lifted is a contradiction, like drawing a square circle. It is not a limit on power, but a limit on meaning. The Omnipotence Paradox also explores the relationship between power and freedom. If an omnipotent being can create a limit, then it becomes bound by that limit, losing its freedom. But if it cannot create the limit, then it is bound by its own nature, unable to act against itself. Either way, omnipotence seems to contradict itself, revealing the tension between power and self-determination. And then, there is the existential dimension. The paradox forces us to confront the nature of existence, the possibility of infinity, the boundaries of thought. It challenges our understanding of possibility, showing that even the most powerful force is bound by the logic of its own being. The Omnipotence Paradox also resonates with theological debates about the nature of God. If God is all-powerful, then can God create a world where free will exists, independent of divine control? Can an omnipotent being create a reality that operates without intervention? If so, then God is limited by human freedom. If not, then human freedom is an illusion. This paradox challenges not only the nature of power, but the meaning of creation, the purpose of existence, and the relationship between cause and effect. It questions whether an omnipotent being is truly free, or whether it is bound by its own perfection, trapped in an existence of unlimited potential, but limited action. And yet, the question remains, echoing through the corridors of thought, reverberating through the halls of philosophy. Can an omnipotent being create a rock so heavy that even it cannot lift it? Perhaps the answer is not found in logic or language, but in the mystery of infinity, the paradox of being. Perhaps omnipotence is not about power, but about understanding, not about control, but about existence. And maybe, just maybe, the rock is not a burden to be lifted, but a question to be pondered, a paradox to be embraced, a reminder that even the greatest power is humbled by the infinite complexity of thought. A rock, heavy with meaning, heavy with possibility, heavy with paradox, forever unlifted, forever unlifted, forever uncreated. The Barber Paradox. In a small village, nestled between rolling hills and winding roads, there lived a barber. He was known throughout the town for his impeccable skill, his precision with scissors, his mastery of the razor. But more than that, he was known for his rule, a peculiar rule that defined his business. The barber shaves all and only those men who do not shave themselves. At first glance, the rule seems simple, straightforward. If a man shaves himself, the barber does not shave him. If a man does not shave himself, then the barber shaves him. But then a question arises, a question so perplexing that it shatters the simplicity of the rule, plunging the village into a paradox. Who shaves the barber? If the barber shaves himself, then according to his rule, he must not shave himself, because he only shaves those who do not shave themselves. But if he does not shave himself, then by his rule, he must shave himself, because he shaves all who do not shave themselves. Either way, the rule contradicts itself. The barber cannot both shave himself and not shave himself. It is a paradox. This is the Barber Paradox, first formulated by the logician Bertrand Russell in 1901. It is a self-referential puzzle, a statement that refers to itself in a way that creates a contradiction. It is a paradox of set theory, of language, of logic itself. Russell's paradox arose from his exploration of sets, collections of objects that share a common property. He asked, does the set of all sets that do not contain themselves contain itself? If it does, then by definition it must not. But if it does not, then by definition it must. The set both contains and does not contain itself, leading to an inescapable contradiction. The Barber Paradox is a simplified version of Russell's paradox, using a narrative to illustrate the logical inconsistency. It reveals the problem of self-reference, the contradiction that arises when a set or statement includes itself in its definition. But the implications go deeper. The Barber Paradox challenges the foundations of mathematics, logic, and language. It shows that self-reference can create paradox that undermine consistency. It reveals the limitations of formal systems, the boundaries of thought. To resolve this paradox, Russell developed type theory, a hierarchical system that prevents self-reference by categorizing sets into types. In this system, a set cannot contain itself, avoiding the contradiction. But this solution introduces complexity, restricting the flexibility of set theory. The paradox also influenced Kurt Gödel and his incompleteness theorems, which proved that in any consistent formal system, there are true statements that cannot be proven within the system. Gödel's proof used self-reference, constructing a statement that says, this statement is unprovable. If true, then it is unprovable, making it true but unprovable. If false, then it is provable, contradicting itself. The Barber Paradox also resonates with the liar paradox, where a statement declares itself to be false, leading to a contradiction. It reveals the challenges of defining truth, consistency, and meaning in language and logic. But beyond logic and mathematics, the Barber Paradox explores the boundaries of identity and selfhood. It reflects the paradox of self-perception, the mind's attempt to understand itself. Just as the barber cannot both shave and not shave himself, consciousness cannot fully perceive itself, for to observe itself, it must stand apart from itself. This paradox challenges the nature of self-reference, the continuity of identity, the structure of thought. It reveals the circularity of perception, the loop of awareness, the mirror reflecting the mirror. And yet, the barber remains, in his shop, scissors in hand, razor gleaming. He stands before the mirror, his reflection gazing back, a man who shaves only those who do not shave themselves. He lifts the razor, hesitates, the paradox echoing in his mind. Who shaves the barber? The question lingers, unanswered, a reminder that some questions have no solutions, that some truths are beyond logic, that some paradoxes are meant to remain. A barber, a mirror, a razor, and a paradox, forever reflected, forever unresolved. The unexpected hanging paradox. Imagine a condemned prisoner, standing before a stern judge in a dimly lit courtroom. The judge declares, "You will be hanged at noon on one weekday next week, but the execution will come as a surprise. You will not know the day until the executioner knocks on your cell door." The prisoner is led away, his mind racing, desperate to solve the riddle of his fate. Alone in his cell, he begins to reason. If the hanging were on Friday, then by Thursday night it would be the only day left. I would expect it, and it would not be a surprise. Therefore it cannot be on Friday. He crosses Friday off the calendar. If Thursday is the last possible day, then by Wednesday night, with Friday eliminated, I would know it must happen on Thursday. It would not be a surprise. Therefore it cannot be on Thursday. He crosses off Thursday. He continues his logic, eliminating each day one by one. By this reasoning, the hanging cannot happen on Wednesday, Tuesday, or Monday either. He concludes that the judge's statement is contradictory. No hanging can occur without violating the surprise condition. Satisfied, the prisoner sleeps soundly all weekend. But on Wednesday at noon, the executioner arrives. The prisoner is taken to the gallows. Utterly shocked, the judge was right. The execution is both a surprise and a paradox. This is the unexpected hanging paradox, a thought experiment that defies logic and twists reason. It exposes a contradiction between predictability and surprise, between reasoning and reality. How can the hanging be both unexpected and inevitable? How can logical deduction lead to a false conclusion? The paradox was first popularized by philosophers M.O. O'Connor and J.F. Thomson in the 1940s, but its origins trace back to medieval logic puzzles. It is also known as the surprise examination paradox, where a teacher announces a surprise test but students try to outsmart the logic, only to be caught off guard. At the heart of the paradox is a self-referential loop, a contradiction between the prisoner's reasoning and the judge's statement. The prisoner uses logic to eliminate each day, concluding that no hanging is possible. Yet this very conclusion makes the hanging a surprise, fulfilling the judge's condition. The paradox exposes the limitations of epistemic logic, the study of knowledge and belief. It reveals the flaw in the prisoner's reasoning. His knowledge is affected by his own conclusions. By believing that the hanging cannot happen, he sets himself up for surprise. This paradox challenges the nature of self-reference and circular reasoning. The prisoner's conclusion depends on his belief about his own knowledge, creating a feedback loop. It reveals the complexity of prediction and expectation, showing that reasoning can undermine itself. The unexpected hanging paradox also explores the boundaries of time and knowledge. The prisoner's reasoning is sequential, eliminating days one by one, but the hanging is a single event, transcending the sequence. This dissonance between linear reasoning and temporal reality creates the paradox. Philosophers have proposed various solutions, but none fully resolve the contradiction. Some argue that the paradox reveals a flaw in temporal logic, the way we reason about time. Others suggest that the paradox illustrates the limitations of self-reference, showing that knowledge about future knowledge leads to contradictions. The paradox also resonates with Gödel's incompleteness theorems and Turing's halting problem, both of which explore the limits of self-reference and prediction. Just as a system cannot prove all truths about itself, the prisoner cannot fully predict his own surprise. But the paradox goes deeper, challenging the nature of expectation and belief. It reveals the fluidity of surprise, the interplay between knowledge and ignorance. It shows that knowing too much can make us blind, that certainty can lead to shock. The unexpected hanging paradox also delves into the nature of free will and determinism. If the hanging is inevitable, then the prisoner's reasoning is futile, his fate predetermined. But if his reasoning affects his expectation, then his belief shapes his reality. It is a paradox of choice, a loop of causality, and then there is the existential dimension. The prisoner stands at the gallows, his mind reeling, his logic shattered. He realizes that the paradox is not just about the hanging, but about life itself, the uncertainty of the future, the inevitability of death, the illusion of control. In the end, the prisoner is hanged at noon, a victim not just of the execution, but of his own reasoning. The paradox remains unresolved, a reminder that logic is not infallible, that knowledge is not absolute, that life is full of surprises. And perhaps, the prisoner finds peace, not in solving the paradox, but in accepting it, in embracing the mystery of the unexpected, the enigma of existence. A hanging, a paradox, a surprise forever unexpected, forever inevitable. The Gettier Problem. Imagine a man named Smith, sitting in a small office, nervously awaiting the results of a job interview. He is confident that his colleague Jones will be chosen. After all, he has strong evidence. The boss mentioned favoring Jones, and he saw Jones with 10 coins in his pocket earlier that day. From this, Smith concludes, the man who will get the job has 10 coins in his pocket. Time passes, and to Smith's surprise, he is informed that he got the job, not Jones. As he reaches into his own pocket, he discovers 10 coins. His belief was true. The man who got the job did have 10 coins. But was his belief knowledge? After all, he based his conclusion on evidence about Jones, not himself. He was right, but for the wrong reasons. This is the Gettier Problem, a philosophical puzzle that challenges the traditional definition of knowledge. For centuries, philosophers believed that knowledge was justified true belief. To know something, 3 conditions must be met. It must be true, you must believe it, and you must have justification for your belief. But in 1963, philosopher Edmund Gettier published a short paper that shattered this definition. He presented scenarios like Smith's where all 3 conditions were met, truth, belief, and justification, but knowledge was absent. Smith's belief was true and justified, but it was based on coincidence, not genuine understanding. It was an accident of fate, not knowledge. The Gettier Problem exposes the fragility of knowledge, the gap between truth and belief. It reveals that justification can be flawed, that reasoning can be misleading, that truth can be coincidental. Consider another scenario. A farmer looks out his window and sees what appears to be his cow in the field. He believes, my cow is in the field. He has justification. He sees the cow. His belief is true. The cow is indeed in the field. But unknown to him, he is actually looking at a cardboard cutout placed by a mischievous neighbor. The real cow is lying behind a tree, hidden from view. His belief is true, justified, and yet, it is not knowledge. This paradox challenges the foundation of epistemology, the study of knowledge. It reveals that truth and belief can align by coincidence, that justification can be insufficient. It forces us to question what it means to know. The Gettier Problem has sparked countless debates among philosophers, leading to attempts to redefine knowledge. Some suggest adding a 4th condition, no false lemmas, which states that knowledge cannot be based on any false premises. In Smith's case, his belief was based on the false premise that Jones would get the job, disqualifying it as knowledge. Others propose reliabilism, the idea that knowledge must come from a reliable process. If the justification is not reliable, then the belief is not knowledge. In the cow scenario, the farmer's vision was not a reliable source, as it was deceived by the cardboard cutout. Then there is causal theory, which argues that knowledge requires a causal connection between the belief and the truth. In Smith's case, there was no causal link between his belief and the actual state of affairs, as the coins in his pocket were unrelated to his reasoning. But each solution faces challenges, leading to new Gettier-like scenarios that defy explanation. The problem reveals the complexity of knowledge, the difficulty of defining truth, the ambiguity of belief. The Gettier problem also challenges foundationalism, the view that knowledge is built on basic, self-evident truths. If justified beliefs can be true by coincidence, then foundations are unstable, knowledge is fragile, certainty is an illusion. This paradox delves into the nature of justification, the reliability of perception, the validity of reasoning. It reveals that knowledge is not merely a collection of facts, but a relationship between truth, belief and understanding. And then, there is the existential dimension. The Gettier problem forces us to confront the limitations of human thought, the fallibility of perception, the uncertainty of existence. It reveals that knowledge is not just about facts, but about meaning, interpretation, perspective. In the end, Smith stands in his office, 10 coins in his pocket, a job he did not expect. He was right, but for the wrong reasons. He believed, but did not know. The Gettier problem remains, unresolved, a reminder that truth is not enough, that belief is not certainty, that knowledge is more than mere coincidence. And perhaps, true knowledge is not about having the right answer, but about understanding the question, about seeking truth, not just finding it, about knowing that we do not know. A problem, a paradox, a truth, elusive, uncertain, forever questioned, forever pursued. The Paradox of Theseus. In ancient Greece, a hero named Theseus sailed across the sea, battling monsters and conquering foes. His ship, a grand vessel of sturdy wood and majestic sails, was preserved as a memorial in Athens, a symbol of his courage and legacy. But as the years passed, the planks began to rot, the sails grew tattered, the oars splintered. To maintain the ship's glory, each part was replaced, one by one, until no original piece remained. Yet, it was still called the Ship of Theseus. But was it? If none of the original materials were left, was it the same ship, or merely a replica? And then, a curious twist. Imagine that all the discarded parts were gathered and reassembled into a ship. There would now be 2 ships, one made of entirely new materials, and another made of the original parts, which, if either, is the real Ship of Theseus. This is the Paradox of Theseus, also known as the Ship of Theseus Paradox, an ancient philosophical puzzle that challenges our understanding of identity and change. It asks a deceptively simple question: when an object's parts are entirely replaced, does it remain the same object, or does it become something new? The paradox explores the nature of identity over time, questioning how things persist through change. If identity depends on material continuity, then the reassembled ship is the real Ship of Theseus. But if identity depends on form and function, then the renovated ship, which continued Theseus's voyages, holds the true identity. This dilemma delves into the concept of mereological identity, the relationship between a whole and its parts. It challenges the mereological principle of extensionality, which states that an object is identical to the sum of its parts. If this principle is true, then the ship with the original parts is Theseus's ship. But if identity is more than mere composition, then the ship that carried Theseus retains the identity. The Paradox of Theseus also resonates with the Sorites Paradox, which questions when a collection of grains becomes a heap. Just as no single grain defines a heap, no single plank defines a ship. Yet, at some point, the change becomes complete. But when? This paradox also challenges the continuity of identity. If each plank is replaced gradually, the transformation is unnoticeable. But if all parts are swapped at once, the change is undeniable. It suggests that identity is tied to continuity, to the narrative that connects the past to the present. The paradox of Theseus is not merely a puzzle of ancient wood. It explores the nature of existence, the persistence of self, the meaning of change. It asks whether identity is physical or conceptual, material or metaphysical. Consider the human body. Cells die and regenerate constantly. Every few years, nearly all the atoms in your body are replaced. Yet, you feel like the same person, with the same memories, the same identity. But are you? If your physical components are entirely new, then what makes you you? This leads to the concept of psychological continuity, the idea that identity is preserved through memory and consciousness. You remember your past, your experiences, your choices. This continuity of thought creates a narrative, a story that ties your past self to your present. But if memories can be copied, then can identity be duplicated? If a perfect replica of you were created, with the same memories and personality, would it be you, or merely an imitation? And if you were gradually replaced, cell by cell, memory by memory, would you remain yourself, or would you become someone else? The paradox of Theseus also explores the boundaries of selfhood. If a person receives an organ transplant, they remain the same individual, but how much can be replaced before they become someone else? A limb, an organ, half of their brain. If the process is gradual, is the change ever noticeable? This paradox resonates with modern technology and the idea of mind uploading, transferring consciousness to a digital medium. If your memories and thoughts are perfectly replicated in a computer, is that digital version still you, or is it merely a copy, a simulation that believes itself to be you? And then, there is the question of duplication. If your mind is copied and placed into two identical bodies, which one is you? Are you both? Or are you neither, with the original identity lost in the process? The paradox of Theseus challenges our understanding of existence. It forces us to question the continuity of identity, the nature of self, and the meaning of change. It asks whether identity is an illusion, a construct created by memory and perception. And yet, we continue to believe in a persistent self. We identify as the same person throughout life, despite the constant change in body and mind. Perhaps identity isn't about physical continuity, but about narrative, the story we tell ourselves about who we are. In the end, the ship of Theseus sails on, its planks replaced, its sails renewed, its oars rebuilt. It continues its journey, its identity both preserved and transformed. And perhaps, identity is not about remaining unchanged, but about continuity through change, about the journey, not the parts. A ship, a self, a paradox, sailing through time, forever changed, forever the same. Zeno's arrow paradox. Imagine an archer standing tall, his bow drawn, the arrow's tip gleaming in the sunlight. He releases the string, and the arrow soars through the air, slicing through the wind, racing toward its target. But then, time stands still. The world freezes, the arrow suspended in mid-air, motionless, hanging between earth and sky. In that single instant, the arrow occupies a specific position. It is not moving forward or backward. It is at rest. But if at every instant the arrow is at rest, then how can it move? How can motion arise from a series of motionless moments? If time is composed of instants, and at each instant the arrow is still, then the arrow must always be still. And yet, it moves. This is Zeno's arrow paradox, one of the ancient Greek philosopher Zeno of Elis paradoxes, designed to challenge the very concept of motion and time. It questions the continuity of existence, the nature of change, the flow of time itself. Zeno argued that if time is composed of discrete instants, then motion is impossible. At each instant, the arrow is at a fixed point, occupying a precise position. It cannot move within that instant, for movement requires time. But if every moment is motionless, then how does motion occur? How does the arrow reach its target? The paradox exposes a conflict between discrete time and continuous motion. If time is a series of separate points, then motion becomes an illusion, a collection of still frames, like the flickering images of a film reel. But if motion is continuous, then time cannot be divided into instants. It must flow without interruption. This paradox challenges the nature of temporal reality, questioning whether time is composed of indivisible moments or an unbroken continuum. It reveals the complexity of change, the ambiguity of movement, the enigma of existence. To resolve the paradox, ancient philosophers proposed the concept of potentiality. They argued that the arrow is potentially in motion, even if it is momentarily at rest. Motion, they claimed, is a process, not a state. But this raises the question, if motion is a process, then how do we perceive it? If every instant is still, then how do we experience change? Centuries later, the mathematician Isaac Newton developed calculus, a mathematical framework that defined motion as the limit of an infinite series of positions over infinitesimal intervals of time. In this view, motion is the result of continuous change, not a series of static moments. The arrow moves because its position is constantly changing, even if each instant is fixed. But then, a deeper question arises. If time is continuous, then it must be infinitely divisible. But if it is infinitely divisible, then how does the arrow traverse an infinite number of points to reach its target? How does it complete an infinite journey in a finite time? This leads to Zeno's dichotomy paradox, which argues that to reach its target, the arrow must first travel half the distance, then half of the remaining distance, and so on, infinitely. If there are an infinite number of steps, then the journey can never be completed. And yet, the arrow hits the target. This paradox challenges the concept of infinity, questioning how an infinite series can sum to a finite value. In the 19th century, mathematician Georg Cantor developed set theory, showing that infinite sets can have finite limits. Using calculus, Augustin Louis Cauchy demonstrated that an infinite series of decreasing distances can converge to a finite sum. The arrow reaches its target because the infinite steps grow infinitely small. But Zeno's arrow paradox is not merely a mathematical puzzle. It explores the nature of time and existence, questioning whether motion is real or an illusion. It suggests that movement is not an object's change of position, but our perception of sequential instants. It challenges the continuity of time, revealing the paradox of presence and absence. The paradox also delves into the philosophy of change and becoming, questioning how something can be both itself and in transition. If the arrow is always at a specific point, then it is always itself, never moving. But if it moves, then it is never fully present at any point. It is always becoming, but never being. This resonates with the philosophy of Parmenides, Zeno's teacher, who argued that change is an illusion, that reality is one, unchanging, and indivisible. Zeno's paradoxes were crafted to support this view, to show that motion, time, and change are contradictions, products of perception, not reality. But then, there is the existential dimension. If motion is an illusion, then what is change? If time is an abstraction, then what is existence? If each instant is motionless, then are we merely frozen moments, strung together by the illusion of continuity? In the end, the arrow flies, slicing through the air, racing toward its target. It moves, and yet, it does not. It exists, and yet, it becomes. Zeno's arrow paradox remains unresolved, a reminder that motion is not merely movement, but a mystery, that time is not merely a sequence, but a paradox, that existence is not merely being, but becoming. An arrow, a target, a moment, a paradox, forever in motion, forever still. The Sleeping Beauty Paradox. Imagine a young woman named Sleeping Beauty, lying peacefully in a chamber, her long hair spread across the pillow, her breathing slow and steady. She has volunteered for an experiment that challenges the very nature of probability, memory, and reality itself. Here is how it works. On Sunday night, she is put to sleep with a special potion. While she sleeps, a coin is flipped. If it lands heads, she will be awakened on Monday. questioned, and put back to sleep with her memory of the awakening erased. She will then sleep until Wednesday, when the experiment ends. If the coin lands tails, she will be awakened on Monday, questioned, and put back to sleep with her memory erased. But she will also be awakened again on Tuesday, questioned, and put back to sleep with her memory erased once more. On Wednesday she will be awakened and the experiment will end. When Sleeping Beauty is awakened, she does not know which day it is. She does not know how many times she has been awakened before. She remembers only the rules of the experiment and the moment she awoke. She is asked a simple question: what is the probability that the coin landed heads? This is the Sleeping Beauty Paradox, a thought experiment that challenges our understanding of probability and self-location uncertainty. It was first proposed by philosopher Adam Elgar in 2000, but its roots trace back to debates in the philosophy of probability and epistemology. At first glance, the answer seems obvious. The coin is fair, so the probability of heads is 1/2. But then, a complication arises. If the coin is heads, she is awakened once. If tails, she is awakened twice. Since she cannot distinguish between Monday and Tuesday, the tails scenario accounts for twice as many awakenings. Should she consider each awakening equally likely? If so, then heads accounts for 1/3 of all awakenings, and tails for 2/3. By this reasoning, the probability of heads is 1/3. This paradox splits philosophers into two camps, halfers and thirders. Halfers argue that the coin flip is a fair event with a probability of 1/2, regardless of how many times she is awakened. Her memory is erased, but the coin's fairness is unchanged. Thirders argue that she should reason based on her experience of being awakened, which is twice as likely if the coin is tails. Therefore, the probability of heads is 1/3. But the implications go even deeper. The Sleeping Beauty Paradox challenges the principles of self-location uncertainty, the uncertainty about one's position in time or space. When Sleeping Beauty awakens, she does not know which awakening it is. Her uncertainty is not about the coin, but about her own existence. This leads to the question of anthropic reasoning, the idea that probabilities are influenced by the observer's position. In this view, probabilities are not just about events but about experiences. Sleeping Beauty's probability of heads depends on how she accounts for her own existence in the experiment. The paradox also resonates with the Anthropic Principle in cosmology, which argues that our observations of the universe are influenced by the fact that we exist as observers. Just as Sleeping Beauty's awakening is influenced by the coin flip, our perception of the universe is influenced by the conditions necessary for our existence. The Sleeping Beauty Paradox challenges the frequentist interpretation of probability, which defines probability as the limit of relative frequency over many trials. In this view, the coin lands heads in half of the experiments, so the probability is 1/2. But it also challenges the Bayesian interpretation, which defines probability as a degree of belief. If Beauty reasons from her subjective experience, she should update her belief to 1/3, because she experiences twice as many awakenings under tails. This paradox delves into the nature of memory and identity. If her memory is erased, is each awakening a separate event, or are they the same experience repeated? Is she the same person each time she awakens, or a different version of herself? If her identity is continuous, then the probability is 1/2. But if her identity is fragmented, then each awakening is a new self, and the probability is 1/3. The Sleeping Beauty Paradox also explores the concept of self-reference and consciousness. When she awakens, she is aware of herself, but unaware of her temporal location. Her consciousness is self-referential, looping back on itself, detached from linear time. It reveals the complexity of self-awareness, the ambiguity of memory, the fluidity of identity. And then, there is the existential dimension. If her identity is fragmented, then her consciousness is not a continuous narrative, but a collection of isolated moments. If her memory is erased, then her past selves no longer exist, and her future selves are mere possibilities. It challenges the continuity of existence, the persistence of self, the nature of reality. In the end, Sleeping Beauty lies awake, her eyes open, her mind racing. She knows the rules, but the answer eludes her. Is the probability 1/2 or 1/3? Is she the same person as before, or a new self, born in this moment of awakening? The paradox remains, unresolved, a reminder that probability is not merely about numbers but about experience, that identity is not merely about memory but about consciousness, that existence is not merely about being but about becoming. And perhaps she realizes that the answer is not in the coin, or the question, or the day, but in the mystery of awakening. The paradox of existence, the enigma of self. A coin, a question, an awakening, a paradox, forever uncertain, forever asleep. Newcomb's Paradox. Imagine standing before two boxes on a table. Box A is transparent, and inside you see $1,000 in cash. Box B is opaque, its contents unknown. You are given a choice: take both boxes, or take only box B. But there's a twist. The game is run by a powerful entity called the predictor, a being so intelligent, so perceptive, that it can predict your choices with near-perfect accuracy. It made its prediction yesterday. If it predicted that you would take both boxes, then box B is empty. But if it predicted that you would take only box B, then it placed $1 million inside. The money is already there or not, based on its prediction. You stand before the boxes, the decision weighing heavily on you. Do you take both, guaranteeing $1,000 but possibly losing the million? Or do you take only box B, risking everything on the predictor's foresight? This is Newcomb's Paradox, a thought experiment proposed by physicist William Newcomb and popularized by philosopher Robert Nozick in 1969. It challenges the foundations of decision theory, free will and causality, revealing a contradiction between two seemingly rational choices. The paradox divides thinkers into two camps: one boxers and two boxers. One boxers argue that you should take only box B. The predictor is almost never wrong. If it predicted that you would one box, then the million is there. If it predicted two boxing, then box B is empty. Since the predictor's accuracy is near perfect, taking only box B maximizes your chances of receiving $1 million. But two boxers argue that the prediction has already been made. The money is either there, or it isn't, regardless of your choice now. Taking both boxes guarantees $1,000, and possibly the million if the prediction was wrong. To them, the choice is about maximizing the present value, independent of the past prediction. This paradox exposes a conflict between causal decision theory and evidential decision theory. Causal decision theory suggests that your choice cannot change the past prediction, so the rational option is to take both boxes. But evidential decision theory suggests that your choice provides evidence of the predictor's foresight, so one boxing is the better bet. The paradox challenges the nature of free will and determinism. If the predictor can foresee your choice with certainty, then your decision is predetermined. But if you have free will, then the predictor can be wrong, contradicting its perfect accuracy. This dilemma also explores the philosophy of time. If the future decision is known, then does the future already exist, fixed and unchangeable? Are you merely playing out a pre-written script, or is the prediction based on probabilities, influenced by your character, your habits, your desires? Newcomb's paradox resonates with the philosophy of mind, questioning whether human decisions are the result of free will or deterministic processes. If the predictor can foresee your choice, then is your mind merely a machine, following laws of cause and effect? Or is consciousness an emergent property, unpredictable and free? The paradox also raises questions about causality and backward influence. If your choice influences the contents of box B, then the present affects the past, violating the principle of causal independence. Yet, if the predictor's accuracy is perfect, then your choice and the contents of box B are correlated, creating a loop of cause and effect. Philosophers have proposed various solutions. Some argue for compatibilism, suggesting that free will and determinism coexist. Others propose backward causation, where the future influences the past. Still, others invoke quantum mechanics, suggesting that the predictor accesses information from parallel worlds or quantum states. But the paradox remains, challenging the nature of knowledge and belief. If you believe in the predictor's accuracy, then one boxing is rational, but if you doubt its power, then two boxing is safer. It exposes the role of belief in decision-making, the influence of expectation on choice, and then there is the existential dimension. Newcomb's paradox is not merely about boxes and money, it is about choice and identity, about the self that chooses and the self that is chosen. It questions whether decisions are acts of free will or the unfolding of destiny. In the end, you stand before the boxes, the decision echoing through your mind. One box or two, choice or destiny, freedom or fate. You reach out, your hand trembling, your mind racing. The predictor has already seen this moment, already placed the money, already foreseen your choice. Yet, in this instant the choice is yours. You take the box, or both, or neither. A decision made, a paradox fulfilled, a question forever unanswered, forever chosen. The paradox of free will. Imagine standing at a crossroads, the sun setting behind you, the sky ablaze with hues of orange and pink. Before you lie two paths, winding into the distance, shrouded in mystery. You feel the weight of choice upon you. Left or right, stay or go, yes or no. The decision is yours, or is it? This is the paradox of free will, a philosophical enigma that questions the nature of choice, the existence of freedom, and the boundaries of destiny. It asks a haunting question. If everything in the universe follows the laws of cause and effect, then are our choices truly free, or are they merely the inevitable consequences of prior events? This paradox arises from the conflict between determinism and free will. Determinism is the view that every event, including human actions, is caused by preceding events in accordance with the laws of nature. If the universe is deterministic, then every thought, every decision, every action is the result of prior causes, stretching back to the beginning of time. If this is true, then all choices are predetermined, and free will is an illusion. Yet we feel free. We feel that we choose, that we decide, that we control our actions. We experience agency, responsibility, moral accountability. If free will is an illusion, then how can we be held responsible for actions that were inevitable? How can there be justice, ethics, or meaning? This conflict leads to the paradox. If determinism is true, then free will does not exist. But if free will exists, then determinism must be false. Yet both seem necessary. Determinism provides order and causality, while free will provides choice and morality. Philosophers have wrestled with this paradox for centuries, dividing into three camps: determinists, libertarians, and compatibilists. Determinists argue that free will is an illusion. They claim that human actions are governed by physical laws, biological processes, genetic predispositions, and environmental influences. In this view, consciousness is merely the byproduct of neural activity, and choices are the inevitable outcome of chemical reactions in the brain. Libertarians, not to be confused with political libertarians, argue that free will is real and incompatible with determinism. They believe in indeterminism, the view that not all events are caused. In this view, human decisions are not predetermined, but are acts of genuine freedom, originating from the self. But this leads to another problem. If actions are not caused, then are they random? If choices are uncaused, then they are arbitrary, undermining moral responsibility. Compatibilists offer a middle ground, arguing that free will and determinism can coexist. They redefine free will as freedom of action, the ability to act according to one's desires and intentions, even if those desires are determined by prior causes. In this view, free will is not about being uncaused, but about acting without external constraint. But critics argue that this merely redefines free will, avoiding the deeper paradox. The paradox of free will also resonates with theological determinism, the belief that an omniscient God knows all future events. If God's knowledge is infallible, then every action is predetermined. But if humans have free will, then God's foreknowledge must be uncertain, contradicting divine omniscience. If God knows my choice, then my choice is predetermined. But if my choice is free, then God cannot know it in advance. The paradox also explores moral responsibility. If actions are determined, then punishment and praise are unjust, for the individual had no choice. But if free will exists, then moral responsibility is preserved. Yet this requires a mysterious freedom that defies causality. In modern science, the paradox intersects with quantum mechanics, which suggests that events at the subatomic level are probabilistic, not deterministic. Some argue that quantum indeterminacy allows for free will, as not all events are predetermined, but randomness does not equal freedom. If choices are random, then they are not truly free, but merely unpredictable. Neuroscience also challenges free will. Studies by Benjamin Libet and others show that brain activity precedes conscious decisions, suggesting that the brain initiates actions before we are aware of them. If the brain decides before consciousness, then free will is an illusion, and our sense of choice is merely the brain rationalizing its actions, yet we feel free. We experience choice, we act, we decide, we change our minds, we live as if we are free, as if our will shapes the world. This paradox delves into the nature of consciousness and identity. If decisions are determined by prior causes, then who is the decider? If actions are the result of neural processes, then what is the self? Is the self merely an illusion, a narrative constructed by the brain, or is there a deeper agent, a soul, a consciousness beyond causality? And then, there is the existential dimension. If free will is an illusion, then life is a script, and we are actors playing predetermined roles. But if free will exists, then we are creators, shaping our destiny, responsible for our choices.
Fate or freedom.
Destiny or decision, script or story. In the end, you stand at the crossroads, the sun setting behind you, the paths before you, winding into the distance. You feel the weight of choice, the paradox echoing in your mind. Are you free to choose, or is your choice the inevitable result of everything that came before? You take a step, left or right, forward or back, a choice made or predetermined, a paradox, forever questioned, forever chosen, a path, a choice, a self, a paradox, forever free, forever fated.